Now that we have loaded the data onto our project in the previous video, now it is time to perform a necessary step of any data science project, that is data cleaning. Data cleaning is a most time consuming and unenjoyable task, but it is important one. You need to keep in mind garbage in, garbage out, no matter how fancy your algorithm is. If your input is garbage, your model will always throw the garbage out. So the model really depends upon the input. So model accuracy or model performance depend upon the input. If you have the input data that is cleaned and well organized, then model will be performing properly and it will give a proper output. But if you have the not clean data, maybe messy data, irrelevant data, then the model will give you the output that is irrelevant and unuseful. So that is the reason we always say garbage in, garbage out. So feeding dirty data into the model will give us the result that are meaningless, and this is important one. So generally we will be walking through these steps. So first of all, we are getting the data. We can do several things to get the data. Maybe we can scrape the data, but for this project we are available with the data that was given inside the transcript folder. Next is to clean the data. So this is the popular text pre-processing technique. Basically we are going to do several things while cleaning the data, and the next one is to organize the data so that we can organize the clean data in the way that is easy to input to our algorithm. So for that we can organize the data. So basically we are going to use these two concepts, corpus and document term matrix. So corpus is a collection of a text. So corpus is nothing but our transcript itself. So if I show you the transcript, then we have inside this transcript folder, or you can also see right here. If I just show you the transcript of, let's say, Ricky Gervais, then these collections of the text can be represented as a corpus. So that is nothing but a corpus. And next one is a document term matrix. So it is kind of a matrix where the word count is represented in a matrix format. So for example, I'll just show you one example. What is document term matrix? So let's say I have a sentence. He is an engineer. This is a sentence. And he works hard. So this is a complete sentence. In fact, the two sentence, but let's say this is here a complete sentence. So here, if you represent this information in the matrix format, then what you will do is you will have this word like he is a Unicode, a engineer. Each of these words will be represented in this way. And again we have the he, but he has already been here, and works is the first time we are encountering this works, and hard is also the first time we are getting this sentence. So let's put it right here, hard. So now we have all the word from this sentence. Now this is the sentence. Now it is time to represent the count. So in this, how many do we have a count in this entire sentence? So in this entire sentence we have a 2 times, we have the he, and is 1 time, and so on. So this is kind of a frequency count. Now if we talk about the document term matrix, we are not going to take only a single sentence, but rather we will have a multiple sentence. And using that multiple sentence, we are going to create a matrix, and if the word is present on that sentence, we will give the value 1 to it. If it is not present, we will give value 0 to it. For example, I'll just take a simple example where we have the 2 sentence. Let's say he is a doctor. So this is the another sentence, just he is a doctor. Now let us create a document on matrix. So first will be like he, and for that I'll just represent it in the column wise. So first word is a he, and next word is, I can see I can see doctor. From the first sentence I can see the he, so he has already been encountered here. Is also there, is also there. Engineer is the first time we are encountering it, so I'll keep engineer. And he works hard, so he is already there. Works is the first time we are getting the word works. Hard is also the first time we are getting this hard. So from the first sentence, see here, he is a doctor. So sentence 1. For the sentence 1, do we have a he word in the first sentence? Yes. Then just keep 1. Do we have is on the first sentence? Yes. Keep 1. Is also there. Doctor is also there. Do we have engineer, the word engineer, in the first sentence? No. So that means the value will be 0 for it. Do we have the word works? So this is work. It come from here. So in the first sentence, do we have, so this is the first sentence and this is the second sentence. So for this first sentence, do we have the works word on it? No. So it will be 0. Hard is also not there in the first sentence, so this is also 0. Now let us check for the second sentence. So we have he, so he is right here, so we will give 1. Is also there, 1. Is also there, 1. Is the word doctor in the second sentence present? No. So there is no word doctor, so it will have value 0. Do we have the word engineer in it? Yes, we have it. We have works also, so just keep it. Hard is also there, so it will be 1. So this way a matrix is created, and this representation is nothing but document term matrix.